everybody, welcome to Crashtest Impact Alert System. Today you're going to be using your code.Node and your code.Node cart to create a Blockly program that halts data collection once an impact has occurred. So let's talk a little bit about this impact alert system and how that relates to a vehicle. Modern vehicles are equipped with an impact or inertia sensor that's fitted on the front, since this is where a collision is likely to occur. The inertia sensor detects a sudden decrease in acceleration of a moving vehicle. This sensor is what triggers the airbag to deploy. This technology, along with your seatbelt, is what protects you in the event of a collision. In this activity, you'll be using Blockly to create a program that mimics an impact alert system that will automatically stop collecting data once an impact has occurred. You'll also investigate how velocity affects the distance a moving object is thrown after a collision, showing the importance of wearing a seatbelt. All right, so right out the gate, you're going to have your Blockly coding challenge, and here are your parameters. All right, so you're going to have to utilize the cart velocity in your program, that hardware block. You're going to have to use your knowledge of how data changes. So you might want to do a few run-throughs and look at some actual data once you release your guy down the ramp here. You are going to need to use a break out of loop. That's important. And you're going to figure that out as you dig more into your program. This might take a little debugging. Do not worry. It's a bit of a challenge. That's the whole point, right? And when you're done, make sure to save your program so you can refer to it back later. All right, so you have your parameters. You have the tools that you need. I went ahead and set up my ramp, which you might want to do ahead of time to get some early data collection to see how you might want to work it in your program. I created a ramp out of just a piece of board. Whatever you have in your classroom will work. And you're going to need 3 books because you're going to do 1, 2, 3 in height, and then a book at the end for your impact or crash zone. All right, go for it. Make that program. Okay, I'm sure that was a bit of a challenge, but I'm sure you were able to do it. Let's take an example program that I've created and see how close you were to what I have. Maybe you did yours better. All right, so I am on my SparkView screen. I'm going to click on sensor data. I don't need temperature, light, or loudness, and I don't need the buttons. And I'm going to click on the bar graph. And let me just show you real quick why velocity was important here, because we're looking at velocity, the max velocity when it hits the book. So let me show you why you use that in your program. I'm just going to start. I won't even have the little guy in here yet. And watch what you see on the screen. All right, you see this point here? That was the max velocity. Right as it was crashing into the book. Those data points will be important. All right, so let's build that program. I am going to create a while true loop. Let me make that a little bit bigger so we can see it well. And my logic statement. I'm going to pull that out. Excellent. And a comparison block. And I'm going to say when the cart velocity, that's direction or speed in a certain direction, is less than or equal to 0. So essentially when I'm saying my cart has come to a rest, I would like the RGB LED light to come on and flash red, or excuse me, not flash, just turn on red. And I want to have a speaker, set that alarm. There it is. Let's put that up to 1,000 hertz so you guys can hear it in the video. And then here's my break out of loop. I'm going to pull that in and put it at the end here. But then I'm going to have an if-else statement. So if the cart velocity is at 0, the red light's going to come on and the speaker is going to come on with a loud alarm, and then it's going to break out a loop, which means it's going to stop collecting data. Else, I can just duplicate these. And if else, I want the light to be green and no sound at all. All right, so that's my example program. Let's see how that works when I roll it down the ramp. Okay, there was a bit of a pause on mine, so I bet you could perfect that on your end, but let me show you why it's doing that. Back in the original program where you look here, we said when the cart velocity is less than 0, meaning it's stationary. I'm going to do a live run again where you're going to notice the cart, but we're going to look at the data so you can see what is triggering it to have the red RGB LED and that alarm. All right, so let's click start. All right, so it stopped collecting data once it hit that 0 velocity, and you noticed it took a little bit of time for it to balance back out because we do have it coming down on the ramp. So that is perfectly fine. It stopped collecting data for us. So that is an example of the program that you could have created. But now you're going to dive in a little bit deeper with this activity, and you're going to answer a question. How does velocity affect the distance a moving object is thrown after a collision? You're going to do it at 3 different heights, 3 trials for each height. You're going to start with 1 book. I have 2 just for this demo. So when you get to that, you're going to measure the height of your ramp here. That's your first measurement that you're going to put in table 1. Then you are going to make sure you have a cart velocity over time graph on the SparkView screen. And I made this nice little car seat for my driver. I'm going to start him up at the top here. I also have a measuring tape that I set up because you're going to actually measure the distance that our guy flies on impact. All right, so I am going to click start, release. Beautiful. I'm going to do it one more time. You might see your guy flying. So as you do each one of your trials, you're going to want to mark about halfway on the body that your guy landed, and you're going to put the measurement on how far he went. So essentially you're seeing if, as you increase the height of the ramp, how does that affect the velocity of the car? Is it increasing? Is it decreasing? And based on that velocity, does that affect how far your little figure goes? And then you have your program set up so data collection stops, so you don't have to worry about that. One more tip, when you're looking for your max velocity, it is that top peak, and you can click on the coordinates tool, and it will give you that max velocity. Here it was 1.20 meters per second. Have a lot of fun with this one, guys. I certainly have a lot of fun doing this, and happy coding.